again, with number 2, we're given the graph of the derivative of f of x. So we need to keep that in mind. We're trying to find out where there's a relative minimum. So before we look at the graph and try and look at the graph to figure it out, first let's think about what we know about relative minimums. How do we know when a function has a relative minimum? What changes from negative to positive? Slope, or the first derivative, right? So the first derivative changes from negative to positive. So that's what we're looking for in our graph. Now, you might get different types of graphs for these questions, but first thing you have to figure out is, what am I looking for? Then look at the graph and what you've got, what you're given, and try and figure out how to find that. So here, we're given the derivative of f of x. Well, we want to know when the derivative changes from negative to positive. Well, the y value represents the derivative. So if the y value is below the x-axis, that means the derivative is negative, right? So for all of this, the derivative is negative, right? It's below the x-axis. The y value gives us our derivative in this graph. So we're not like looking at the slope of this graph. The slope of this graph would be our second derivative, and like we saw in the last problem. All right, so here the derivative is negative, then up here our derivative is positive. So what's happening right here when x is 3? It's going from negative to positive, right? The derivative is changing from negative to positive at 3. So since it's changing from negative to positive, that's going to give us our relative minimum. Now, because this is the derivative first derivative is changing from negative to positive. If it were the second derivative changing from negative to positive, that'd be an inflection point. Let's say you're having a hard time with these graphs. One thing that you can do is transfer it to a number line, because we've done a lot of that, and I think people are pretty comfortable looking at the number lines. Remember, the number line, first thing we put on there are the critical values, where the derivative is 0. So derivative is 0 here and here. So we have critical values at -1 and 3. Then just look at the derivative. In this case, the y value is the derivative. So to the left of -1, all the y values are negative. Between -1 and 3, all of the y values are negative. Then from 3 on, all the y values are positive. So we can see here the derivative changes from negative to positive at 3. So that's where we're going to have our minimum.